going on? I hear the sound again. What's that? Oh, I see. I see this girl. Okay, there's a screeching sound. A screeching to a halt. One more time again, can I hear it? She's not a car. She's one of my students. Like you, my dear. Screeching to a halt. Well, today, our topic will be rate of change. Alright? We talk about rate of change, an area under the graph. It will be about distance time graph. Alright? And we've got to do speed and time. Now, it looks kind of, you may get put off, but don't. It's something really interesting. I told you maths is magic. But today is strange. You know what happened? In the morning when I opened my papers and I saw the headlines, moral plus maths. Moral plus maths. Oh, wow, what's that? Okay, moral plus maths equals to what the new curriculum in maths in Singapore is going to be. But I said, I'd like to let you know. Well, we always learn maths with lots of good stories. Remember I shared with you? I believe there's always this moral component there. I believe you can fly. I believe you can achieve. And that feeling of character in you, mixed with maths, becomes a very powerful combination. Alright? So moral plus maths gives you fun, real good fun, and real maths in your life. And of course, if you get maths right, in your long term, you're gonna make lots and lots of money. Alright, but provided maths comes to you. Alright, my dear, Mrs.kuamr will be fun. Alright, now let's have you, I'm sure you go up and down the lift. Okay? And let's look at this question. Imagine you're in the lift. The table below shows the height in meters and the time in seconds. Now you look when you're 0, of course it's at 0, ground level. And then when you go up and spend more time in the lift, you find the height is going higher and higher and higher. At one point, 10. At 10 seconds, you're 15 meters up there. And then right up to 14 seconds, there's no distance moved. Alright, so that's a rest, a halt of the lift. Maybe someone's alighting or embarking or whatever is happening then. Then you look at 16 seconds, you go down from 15 to 12 meters, and then you go to 9 meters. At the 20th second, you're 6 meters above the ground. Now when you looked at this data, you want to convert it into a distance time graph. Alright? A distance time graph. And you're going to look at it further and analyze. So let's do the analyzing of this data. Now the time of this graph, let's look from 0 to 20. I'm going to just do a very approximate one. As I told you, we just want to get the concepts there more than getting the accuracy. So I just want to teach you a concept. From 0 to 20, let's put it 2, 4, oh, that's not enough, 6, 8, not enough. Alright, I put 4, 6, 8, 12. Alright, maybe 4 will do. 4, 8, 12, 16, 20. Let's put it that way. And the distance, the highest distance is 15 meters. I'm going to put time, I'm afraid. Oops, human error. When we decide on the axis, alright, I was so anxious in putting my time up. I would have to look a bit closer at it and said, now we have 2 points here. One is time and the other one is height. Now we want to find out my main purpose of distance time graph. What is it? Distance against time. Distance against time. So here, I went to put time. Time against distance doesn't sound right. Alright, with the time, I want to see the distance. So my focus has been right. Kuamr, come on! Alright, so let's look at it, be focused. So we put here as height. When we put it as height, The unit of measurement is m. Now it's up to 15. I suppose I will stick to this measurement for 8, 12, 16, 20. Or maybe I can put it as 3. That would be better even, because I look at the reading and it tells me that it's in multiples of 3. So let's change it to an easier mode. 3, 6, 9, 12, 15. And of course that will be 18. Now as for this is time. And what is the unit of measurement of time? The measurement is in seconds. So we put it in seconds. Now we're going to plot the graph, but before that we've got to calibrate this up to 20 seconds. So if I put here 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Ooh la la, got it. So let's write it. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now we're going to draw. We said A, 0. You're at 0. Now, this is 0. Now, when it at 2 seconds, you are what height? You are at 3 meters above the ground. At 4 seconds, you are 6 meters above the ground. And 6, you are at 9 meters here. All right? And then at 8 seconds, you are 12. So look at it. And then you at 10, you go to 15. 15 is about there. As I said, this is an approximate diagram. I just want to teach you concepts. But my dear boys and girls, when you do this, you do not follow me. Alright, I'm not sitting for any exams, it's you. So you've got to be very accurate in your calibration. My objective here is to teach you and you do it right. Okay? So we join this here. This is a straight line. Wow, I'm so happy I got the straight line. And this is when it's 10 seconds, you reach a maximum height of 15. And you stay at 15 seconds from 10 seconds to 14 seconds. Right up here, you're at 15. So here too, you're 15. All right? And then from there, what happens? From the 16th second, you drop to 12. I just draw this approximation. You are at 12. And then at the 18th second, you come to 9. Okay? 9. And the 20th second, you are at 6. 6 is somewhere here. So look at the graph. Look at it. We have translated this whole data of information into a graphical representation. And as I told you, my dear, a graph, a picture is worth 1,000 words. Remember Venn diagram? VD. I told you, not venereal disease. It's Venn diagram, all right? So manage your raging hormones. What is RH? Raging hormones. If you don't manage it, and if you don't let it go wild, then all these STI, VDs become a problem. So stay away from it, my dear. Grow in a natural, intelligent way. Be aware of the surrounding and stay good. Let your moral compass guide you. Moral compass guide you in the field of maths. Have more fun as you learn maths, and then in the later years, you will see the dollars coming in. And that's when all the beautiful girls will come into your life, and so will the great man. Stay cool, stay calm. Let's get back to maths. Great. Now you look at this whole thing, my dear, the graphical representation of information. What does the slope tell you? Yes, it tells us how the steeper it is, the faster you're moving, the lift is moving. The slower it is, all right, the more gradual it is, it's not moving like here, all right? So when you have a distance, this is a distance time graph. Shall I write it here? It's a distance because height is distance. It's a distance time graph. Okay? This distance time graph will tell you when no distance is moved. Alright? The velocity here is 0, or you can call it the speed. The difference between, okay, we talk about speed, okay, there's just no direction, that's all. We talk about velocity, that's showing you direction. But let me call it as velocity or speed. I hope you don't get it misconstrued. It's just about direction. So here, the velocity, or I should cut this and make it easier for you, the speed is 0, all right? And 0 meters per second, we call this resting. The lift has come to a stop, all right? Lifts come to a stop. So no distance moved. And that means rest, if you were to equate it to resting. If you are moving and I stop, rest. Move, stop, rest. That means no distance is moved. All right, and then you look at the slope downwards. There's a change in direction. A change in direction because the lift was going up and now it's going down. Okay, so let's find out a little more from this graph. At this point, look at the speed of the graph when it's 10 seconds. What is the speed? All right, we want to find out the speed. Okay, I'll give you the speed when t is equal to 10 at 10 seconds. Well, the speed is equals to distance over time. What is the distance moved from 0 to 10? Look at it, my dear. 15. 15 meters in 10 seconds. You reduce it, it will be 3 over 2 meters per second. Got it? Great. Now, what about the speed when t is 8? Or let's put t is 6. What is the speed when t is 6? Look at it. What is the speed when t is 6? I'm going to say this S1, T1. This is S2, T2. What is S2 going to be? The distance traveled in 6 seconds is 9 meters. Yes, in 6 seconds. So you put it here, 9 over 6. You see, you've got something that you discovered. What can you say? The speed is constant from 0 to 10 seconds. It's the same speed, my dear. It's the same slope. So that's why any point here, the speed will be 3 over 2 meters per second. Now, can we really try to understand what is meant by it? This is 3 over 2 is 1.5 meters. Now, I would say 1.5, this is 1 meter from here to here. 1.5 meters is somewhere around here. All right, 1.5 meters. It means in 1 second, you travel 1. That's the meaning. 3 over 2 meters per second means you travel 1.5 meters per second. I want this logical, real meaning done. Can you travel 10 meters per second? Can you? Are you a bird? Are you a plane? What are you? So you got to know, all right, meanings, okay? If you say, the car moved at 10 kilometers per hour, what does it tell you about the driver? Really slow. All right, you can change, convert, and you see what is 10 kilometers per hour, and look at that. So speed is something I need you to understand the meaning. Here is every part of this until 10 seconds, you're moving at 1.5 meters per second. Now, as for this case, it is 0, right? No distance moved over time, all right? There is 0 speed. Now, if you look at the time, the resting is from 10 to 14 seconds. There is a 4 seconds resting, a break, a stop, a halt. Okay, now let's come to the second part of it. What about this part of it? Okay, we look at it and said, now it's dropping. The lift is going downwards, it's a descent. And you look at this when S3, you want to find out. When T is, like say, 16 seconds, all right, when T is 16 seconds, you want to find out from 14 to 16 seconds. I want to find out that speed between 14 to 16 seconds. So I've got to give you, because this is a change. If I put up to 16 seconds, then I got to look at total distance divided by total time. I'll come to that later on. But from 14 to 16 seconds, look at the distance traveled. 14, where are you? Look at the point. When t is 14, okay, the distance is 15 meters. When t is 16 seconds, the d is 12 meters. So the speed will be equals to distance traveled. If you start from here, 14 or minus 16, or you can put as 16 minus 14, then the distance will be from here minus here. Okay, let's put it. If this is T1, T2, D1, D2, if you put it as D1 minus T2 minus D1, then it will be T2 minus T1. Let's get that. Do not mix it up, because that's when the signs will change. So your D2 is 12, 12 minus 15, and here your time is 16 minus 14. We've got a minus 3 over 2 meters per second. Look at that. Okay? If you look at it, minus 3 over 2 meters per second. Now, if I just want to go back to this again. I put as D2 minus D1 over T2 minus T1. If I put it as D1 minus D2, let's look at that. And T1 minus T2. Your D1 is 12 minus 15. Oh, sorry. Your D1 is 15. All right, let's look at it. Your D1, when you look at D1, is 15 minus 12. Over, what is it? D1 and T1, 14 minus 16. So you can see that 15 minus 12 is a 3 over a minus 2. You still get the same answer, my dear. Okay? You get a negative speed. What do you mean by negative speed? Alright? A negative speed shows that the lift, the speed, the direction is changed in the opposite way. Not that it's lesser. Because here, the speed is equal to 3 over 2 meters per second. Whereas here, the speed is equal to minus 3 over 2 meters per second. They both travel at the same speed, but just that one was going upward and the other one was going downward, and they have the same speed. But if we want to find the average speed of the whole thing, the whole journey, can you tell me what is it? Right, average speed will be equal to total distance over total time, and you can include the rest time. So what is the total distance traveled? Look at it from here to here. It's 15, and from 15 you travel right up here. Look at that here again. Okay, from 15 to 9 is another 6. So you're going up 15, and then you went down to, oops, you went down to 6 here, I'm sorry. Went down to 6. So look at that. So from 15 to 6, that's another 9 meters. And from here you went up 15. So the upward movement of 15 meters, the downward movement of 9. The total will be 15 plus 9 divided by the total time. The total time is 20 seconds. So look at that, add on. You've got 24 over 20. Reduce it. You have 12 over 10. So your average speed is 1.2 meters per second. Do you see that? When earlier on your speed was 1.5. Why did the speed drop? Because it stopped. Now don't get so worried. We'll have more examples, my dear, as we do more sounds with distance and time. Stay cool. Take on a nice cold chill drink. Come back to your table, and we'll buzz more on distance time. Can I hear a hot sound again? Oh, stop my lesson! Oh, Come back to me again shortly. I'll see you more on distance time graph.